Prehistoric animals were terrifying, but for prehistoric humans, life was an unrelenting nightmare. From battling monstrous predators to enduring the harshest environments imaginable, survival was a daily fight against horror itself. In this video, we dive into the brutal realities of prehistoric human life and uncover just how nightmarish it truly was. Modern humans are living in an age of unprecedented luxury. With a global life expectancy of 73 years and endless access to technology, medicine, and comforts, it might feel like we've hit the ultimate jackpot of human existence. But our journey to this golden age has been a brutal one. Just a few centuries ago, life expectancy in 18th century France hovered around 30 years. Go further back to classical Greece, and it dropped to 25 years. In the Neolithic period, a bleak 20 years. And if you think that's grim, the lives of some ancient relatives make these numbers look almost luxurious. Homo sapiens have undoubtedly faced struggles, but compared to other human species, we've had it shockingly easy. Evidence of horrifyingly violent deaths regularly emerges from ancient remains, painting a vivid picture of just how savage survival used to be. So, next time you're having a bad day, remember this. Some of our ancestors' lives were so brutal that bad day doesn't even begin to cover it. Among all human species that have ever existed, one group stands out for having experienced perhaps the most nightmarish existence imaginable. Recent research has revealed that Homo habilis, who lived around 2 million years ago, faced such extreme mortality rates that most individuals never even reached their teenage years. The average life expectancy? A mere 12 years, more than 6 times shorter than our current average. Even more disturbing, this figure might be optimistic. The study, which examined 26 random specimens, noted a conspicuous absence of infant and newborn remains, suggesting the actual mortality rate was likely even higher. This makes Homo habilis not just an early human species, but quite possibly the most unfortunate one to have ever walked the earth. Which raises the question, what made their lives so incomprehensibly brutal? For Homo habilis, the deck was stacked against them from the start, beginning with their own bodies. As one of the smallest human species ever to exist, they typically stood less than 1.2 meters or 4 feet tall, making them about 32% shorter than modern humans. In terms of weight, they were even more diminutive, reaching only about 60% of our average mass. This small stature alone made them vulnerable. But to make matters worse, their skeletal structure showed no particular robustness that might have compensated for their lack of size. Their physical challenges were further complicated by their semi-arboreal lifestyle. Like modern chimpanzees, they spent considerable time in trees. They possessed somewhat ape-like features, including longer limbs relative to body size and modified extremities that aided in climbing and branch swinging. While these adaptations helped them navigate their arboreal environment, they likely experienced at least one serious fall during their lifetime, similar to what's observed in modern chimps. While their ability to climb might seem advantageous for avoiding danger, this benefit was largely negated by their surprisingly carnivorous diet. These early humans exhibited one of the highest levels of meat consumption among all human species, evidenced by their notably large incisors designed for cutting through flesh and their extraordinarily thick mandibles, more robust than those of any living ape or human. These powerful jaws allowed them to generate exceptional force while biting, perfect for tearing meat from carcasses. Though they maintained a mixed diet including fruits and vegetables, their heavy reliance on meat forced them to regularly leave the relative safety of trees. Their situation was further complicated by a fondness for fish, which required them to venture near dangerous water sources. Most puzzling was their specialization in scavenging, a remarkably risky strategy for a species with their physical limitations. According to research, they could only reliably defend carcasses from smaller predators like jackals and cheetahs, a nearly meaningless advantage in their East and South African habitat, where they faced numerous larger carnivores that would not only compete for carrion, but also view the habilis themselves as prey. While scavenging and dietary challenges placed Homo habilis at great risk, they also faced a more insidious threat from within: parasites and disease. These hidden dangers plagued their bodies, compounding the difficulties of survival in their harsh environment. Living near water sources exposed Homo habilis to a variety of parasites, including blood-sucking insects such as mosquitoes and tsetse flies. These insects carried devastating diseases such as malaria and sleeping sickness, which would have been deadly for a species with limited immunity and no access to treatment. The tropical climates of East and South Africa created a perfect environment for these pathogens to thrive, ensuring that disease was a constant and silent killer. Their scavenging lifestyle introduced additional risks. Consuming meat from carcasses exposed Homo habilis to harmful bacteria and parasites. Without the ability to properly cook or preserve food, infections such as salmonella, botulism, and intestinal worms were likely common. Intestinal parasites, such as hookworms and roundworms, would have drained essential nutrients, weakening their bodies and making them more vulnerable to injury and other illnesses. Even their arboreal habits introduced dangers. Spending time in trees brought them into close contact with zoonotic diseases, pathogens that could jump from animals to humans. Bats, rodents, and other creatures sharing their environment may have transmitted early forms of viral or bacterial infections, further burdening their already precarious health. Additionally, the lack of sanitation posed ongoing challenges. Contaminated water sources were a breeding ground for waterborne diseases like dysentery, further contributing to high mortality rates. Fossil evidence of bone infections and abscesses suggests that even minor injuries often turned fatal due to a lack of basic wound care. The constant toll of parasites and disease weakened Homo habilis physically, making their survival even more precarious. For a species already struggling with limited physical strength and high mortality rates, these hidden killers silently shaped their brutal existence. For a Homo habilis, each day brought the constant threat of becoming someone else's meal. They lived under the shadow of an incredibly diverse array of predators, each with their own horrifyingly efficient methods of killing. The fossil record has identified over 30 potential predators that shared their habitat, with large cats being particularly problematic. The Megantereon, a stockily built saber-toothed cat the size of a jaguar, was one of their most frequent tormentors. Despite its moderate size, it possessed disproportionately large lower limbs, comparable to those of a lion, ending in massive paws armed with wickedly curved claws. Once these claws grabbed hold of a Homo habilis, the victim would experience an arsenal of sharp, serrated teeth, including 2 enlarged canines that would plunge into their throat, severing major arteries and nerves. While this typically led to mercifully quick unconsciousness, some victims faced an even more terrifying fate, having their entire head engulfed by the predator's jaws. This horrifying hunting method has been confirmed through fossil evidence, with one human specimen showing puncture marks on the occipital bone, the back of the skull. The angle of these marks revealed something chilling. The attack came from the front, meaning the Megantereon had literally put the human's entire head in its mouth. This hunting technique likely caused death through a combination of skull and brain damage, along with suffocation as the victim's nose and mouth were completely covered by the predator's jaws. The Megantereon's taste for Homo habilis was so pronounced that it actually altered their carbon isotopic levels, indicating they killed humans more frequently than other predators known for hunting early hominins, such as the equally fearsome Dinophalus. And the Dinophalus was just one of several other large cats prowling their territory. Even more terrifying was the Machairodus, one of the largest phalids ever to exist. Some species of this massive predator reached weights of 405 kilograms, comparable to both a Smilodon and a modern male polar bear. At this size, even a casual swipe from its paw could prove fatal, especially considering that many victims appeared to be younger individuals. What made the Machairodus particularly deadly was its surprising agility. Despite its enormous size, it was actually a better jumper than many smaller, more agile cats. While its relatively short legs made it poorly suited for extended chases, they provided the power for explosive leaps that made escaping up a tree a futile strategy. The slightly smaller Homotherium was no less nightmarish. While its canines and incisors were shorter than those of other saber-toothed cats, they were notably broader and featured unique crenulations, irregular, wavy serrations that created a devastating bite that simultaneously punctured and sliced through flesh. While big cats were undoubtedly terrifying, they weren't the only predators that made life miserable for Homo habilis. Hyenas proved to be equally nightmarish threats, with 2 species in particular standing out for their human hunting capabilities: the Cosmoporthetes and Pachyrhinacuta. True to the cruel luck that seemed to plague Homo habilis, the Pachyrhinacuta happened to be one of the largest hyenas ever to exist. These monsters matched lionesses in size, but possessed what may have been the strongest pound-for-pound bite force of any land mammal. This extraordinary bite strength wasn't just terrifying in itself. It meant they could easily crack open bones to access marrow, making them fierce competitors at the scavenging sites our ancestors depended on. Making matters worse, Pachyrhinocuta likely hunted in packs, multiplying the horror factor significantly. And like modern hyenas, they were known to consume their prey while it was still alive, a fate that would rank high on any Homo habilis' list of ways not to die. If Pachyrhinocuta represented the heavyweight champion of hyenas, Chasmoporthetes was its more agile, but equally lethal cousin. These so-called hunting hyenas were more gracile and nimble, likely hunting in large packs with devastating effectiveness. Their smaller size might initially sound like good news, but having a large pack of dog-like hyenas eating you alive was arguably worse than a quick death from a larger predator. What made Chasmoporthetes particularly dangerous was their specialized limb structure, which bore striking similarities to those of modern cheetahs, earning them the nickname running hyenas. This adaptation for extreme speed was especially problematic for Homo habilis, who were, at best, capable of only moderate endurance running. To make matters even worse, these hyenas were hypercarnivores, meaning over 70% of their calories came from meat. Their razor-sharp teeth, peculiarly shaped like those of big cats, made them exceptionally effective predators. As if dangers on land weren't enough, Homo habilis also faced horrifying threats when they ventured near water. Their fishing activities brought them face-to-face with massive crocodiles that seem to have developed a particular taste for early humans. Two species stand out in the fossil record: Crocodylus anthropophagus and Crocodylus thorbjarnarsoni. The name anthropophagus literally translates to human eater, and fossil evidence gruesomely confirms this title. Paleontologists have uncovered remains of young Homo habilis individuals bearing severe damage to their legs and feet, matching the distinctive bite patterns of these ancient crocodiles. These attacks likely occurred when our ancestors attempted to fish by hand near the water's edge, making them perfect targets for ambush predators. At 7.5 meters or 25 feet long and weighing approximately 1.5 tons, C. anthropophagus dwarfed even the largest modern saltwater crocodiles. For comparison, Lolong, the largest recorded saltwater crocodile, measured 6 meters or 20 feet and weighed 1.1 tons. The ancient predator's skull featured prominent ridges above its eyes, giving it a demonic appearance while providing additional protection. Combined with its armor-like hide, this made it virtually invulnerable to any defense a Homo habilis might attempt. Even more intimidating was Crocodylus thorbjarnarsoni, stretching over 8 meters or 26 feet in length, the largest true crocodile ever discovered. Its broader skull was particularly well adapted for crushing armored prey like large turtles, but it wouldn't hesitate to seize any unfortunate human who strayed too close to the water. The hunting strategy of both species appears to have been similar: ambush attacks targeting the legs to drag victims into the water, where either drowning or the infamous death roll would finish the job. While predators posed the most immediate threat to Homo habilis, they faced numerous other challenges that made their lives even more difficult. The African Pleistocene environment was unforgiving, with dramatic climate fluctuations forcing them to constantly adapt to changing conditions. During periods of extreme cold and aridity, their mixed dietary strategy became crucial for survival, though it exposed them to greater predation risks. Even seemingly peaceful herbivores posed significant threats. Territorial disputes with prehistoric rhinos, hippos, and elephants could prove just as deadly as predator encounters. Modern hippos alone caused thousands of human deaths annually in Africa, and their ancient relatives were likely no less aggressive. These confrontations would have been particularly frequent around water sources, where Homo habilis needed to venture for fishing and drinking. Competition with other hominin species added another layer of complexity to their struggle for survival. Fossil evidence shows that Homo habilis shared their territory with several other early human species, including Homo erectus and Homo rudolfensis. These species often possessed advantages such as larger brains, better tools, or more specialized adaptations. In some cases, these interactions turned violent. Despite their numerous challenges, Homo habilis possessed one significant advantage that helped them survive their brutal world. They were the first of our relatives to systematically create and use stone tools. This technological innovation earned them their name, which means handy man, and marked an important development in their ability to adapt to their environment. Their tools, while primitive by modern standards, allowed them to access food sources that would have otherwise been unavailable. They could crack open bones to extract nutritious marrow, process tough plant materials, and more effectively butcher scavenged carcasses. Some evidence suggests they may have even constructed basic shelters or windbreaks to protect themselves from the elements. Recent studies of their brain structure, based on fossil endocasts, indicate they possessed cognitive capabilities beyond what was previously believed. Their brain size, while modest at 600 to 800 cubic centimeters, represented a significant increase from their Australopithecine ancestors. This enhanced cognitive capacity likely allowed them to anticipate threats, plan scavenging strategies, and possibly even develop early forms of social cooperation. Archaeological evidence suggests that Homo habilis lived in groups of up to 85 individuals, likely as a defense against predators and to improve their chances of successful scavenging. This social structure may have included early forms of division of labor, with different group members specializing in various tasks like tool-making, food gathering, or keeping watch for predators. Analysis of their skull bases and ear structures suggests they may have been capable of producing and perceiving a range of vocalizations more sophisticated than those of great apes, though still far from modern human speech. This early form of communication would have been crucial for coordinating group activities and warning others of dangers. Their average lifespan of 12 years, likely even lower when accounting for infant mortality, reflects the incredible harshness of their existence. Yet despite facing some of the most challenging conditions any human species has ever encountered, they managed to survive for nearly 700,000 years. Their persistence in the face of constant danger, their innovative use of tools, and their ability to adapt to various challenges were key to their survival. While their lives were undoubtedly brutal, their struggles and adaptations contributed significantly to the development of skills and behaviors that define humanity today. Being Homo habilis was, without question, one of the most challenging times to be human. Their world was filled with constant danger, from massive predators to environmental challenges, and their own physical limitations made survival a daily struggle. Yet, as remarkable as their story is, they were just one part of the fascinating history of early humans. If you thought Homo habilis faced intense challenges, wait until you learn about their distant cousins. Neanderthals, often misunderstood and underestimated, were truly the ultimate freaks of nature.
Among all ancient human species, none captivate us quite like the Neanderthals. These resilient beings bore a striking resemblance to us and shared deep genetic ties, making them not just figures of history, but part of our very DNA. Today, most of us carry fragments of their genes, living echoes of a species that roamed Eurasia between 400,000 and 40,000 years ago, in a world of brutal climates and colossal beasts. During the Pleistocene era, the Neanderthals rose to these challenges, cementing themselves as some of the toughest humans ever, with a biology so remarkable it would make them seem almost superhuman by today's standards. From a distance, their anatomical differences to modern humans would not be immediately obvious, with their height being one of the most distinguishing features. Recovered specimens indicate that on average, Neanderthals stood about 14 centimeters or 5.5 inches shorter than post-World War II human populations. However, when compared to European populations from 20,000 years ago, Neanderthals were actually equally as tall, if not slightly taller. The tallest known Neanderthal individual, nicknamed Ahmoud 1, is estimated to have been around 1.78 meters or 5 feet, 10 inches in height, not particularly towering, but still quite impressive for the time. Where Neanderthals truly stand out is in their weight and muscularity. Despite being shorter than modern humans, they were significantly more robust, with the average male Neanderthal weighing up to 83 kilograms or 183 pounds, and the females typically around 66 kilograms or 146 pounds, approximately 20% heavier than their Homo sapien counterparts. The reason for this paradoxical build lies in their incredibly dense and compact skeletal structure. Neanderthal bones were substantially thicker and denser than ours, sometimes even twice as dense, with their shoulders, femurs, chests, arms, and other major joints displaying a remarkably muscular and powerful appearance. This muscular build was likely an adaptation to their hunting tactics, which involved wielding massive spears to take down large prey such as woolly mammoths, rhinos, horses, and various other megafauna. The sheer strength required to hurl these giant spears with enough force to bring down such massive animals is staggering to imagine. The pronounced muscularity and definition of Neanderthal arms may also point to elevated hormone levels, according to one study. Researchers suggest that Neanderthals likely had high natural hormone levels that contributed to their impressive muscle mass and enabled them to perform remarkable feats of strength, such as carrying up to 27 kilos or 50 pounds of meat over distances as long as 30 miles or 48 kilometers, which is equivalent to walking 138 laps around a soccer field. Adding to this impressive strength, scientists believe that Neanderthal males could have bench pressed up to 200 kilograms or 500 pounds without any training, while the females may have been capable of 160 kilograms or 350 pounds, feats that would be considered elite level by today's standards, even for the most dedicated powerlifters. But Neanderthal strength was not just for show. It also granted them incredible durability. Analyses of recovered skeletons have revealed that between 79% and 94% of Neanderthals showed signs of severe, healed injuries, ranging from blunt force fractures to traumatic amputations. One particularly gruesome case involves an elderly Neanderthal who, in his younger days, had lost his right arm, damaged his left clavicle, sustained massive facial injuries that blinded him in one eye, and had his ear canals completely closed off by new bone growth, rendering him deaf in both ears. Yet, he somehow managed to survive all of these devastating traumas. This high prevalence of extreme injuries is thought to have stemmed from a combination of Neanderthals' aggressive face-to-face hunting techniques, interpersonal conflicts, and encounters with dangerous predators. Interestingly, the latter seems to have been a common occurrence, with nearly 74% of Neanderthal remains showing evidence of having survived violent animal attacks, mainly from big cats, wolves, and bears. What's even more remarkable is that scientists believe these attacks were not merely predation attempts, but rather the animals defending themselves against the Neanderthal assaults. Talk about hardcore. To complement their robust physiques, Neanderthals also possessed several other superhuman biological traits. For instance, their lungs were approximately 20% larger on average than those of modern humans, with some exceptional individuals like the male Neanderthal, known as Kabara, too having a lung capacity of 9 liters, 40% greater than the largest ever recorded in a human athlete. This enhanced respiratory system, combined with their wide, elongated noses that could move air up to 100% faster than ours, was likely an adaptation to support their heavy bodies and survive in the frigid Pleistocene climate. Neanderthals' muscular prowess, however, was not evenly distributed across all physical activities. While they were undoubtedly powerful sprinters and wrestlers, capable of generating immense bursts of force, they were surprisingly poor endurance athletes. This is evident in the structure of their lower limbs, which favored power over stamina. Their toes were longer and wider for increased ground contact and force generation. Their leg bones were shorter, and their Achilles tendons were narrow and less elastic. All traits that are typically associated with speed-focused activities rather than long-distance running. Additionally, genetic analysis has revealed that Neanderthals had a higher proportion of fast-twitch muscle fibers compared to modern humans, further indicating their predisposition towards explosive, short-duration movements rather than sustained aerobic exercise. So, if by some miracle Neanderthals were to come back to life today, your best bet would be to challenge them to a marathon rather than a weightlifting competition or a wrestling match. While Neanderthals' physical prowess is undoubtedly impressive, their cognitive abilities have also been a subject of fascination. One of the most striking features of Neanderthal anatomy is their enormous brain cases, which were on average about 30% larger than those of contemporary humans. The male Neanderthal brain is estimated to have had a volume of around 1,640 cubic centimeters, while the female brain was typically around 1,460 cubic centimeters. This massive brain size is a clear indication that Neanderthals were highly intelligent, capable of complex tasks such as tool-making, coordinating hunts, creating art, and caring for the sick. However, their brain structure was quite different from ours, with a more circular, bomb-like shape that was adapted to support their large bodies and enhanced sensory capabilities, particularly in the areas of smell and vision. Neanderthal eyes were also remarkably large, about 15% bigger than modern human eyes, which would have provided them with superior night vision and sharper overall eyesight. This improved visual acuity, combined with their enlarged occipital lobes, suggests that a significant portion of their brain power was devoted to processing visual information, rather than the more balanced cognitive functions seen in Homo sapiens. Despite their impressive brain size, researchers do not necessarily believe that Neanderthals were intellectually superior to modern humans. The structural differences in their brain anatomy may have limited their cognitive flexibility and problem-solving abilities in certain domains, even if they excelled in other areas like spatial reasoning and visual processing. One intriguing theory about Neanderthal intelligence is that their large jaws and teeth were not just for tearing into tough meat and bones, but also served as a third hand of sorts. Some researchers believe that Neanderthals used their front teeth to grip and manipulate various objects, freeing up their hands for other tasks. This hypothesis is supported by the unique wear patterns found on Neanderthal dentition, which suggests they engaged in a lot of tooth-based manipulation that is not seen in modern humans. Another fascinating aspect of Neanderthal biology is their dietary habits. Isotopic analysis has revealed that they were essentially hypercarnivores, with up to 70% of their massive caloric intake coming from meat alone. This would have required them to consume an astounding amount of animal protein and fat to sustain their large, muscular bodies. Interestingly, the bulky nature of their teeth may have been an adaptation to efficiently process this predominantly meat-based diet. So, what impact does all of this Neanderthal biology have on modern humans? Well, the short answer is, not as much as you might expect. Despite the widespread presence of Neanderthal DNA in contemporary populations, most studies have failed to find any significant effects on physical attributes or athletic performance. While there are a few emerging studies suggesting potential impacts on our internal systems, the scientific consensus remains that Neanderthal DNA typically only has subtle, if any, influences on modern human traits. That said, the sheer amazement surrounding Neanderthal biology and capabilities is a testament to the incredible adaptations that allowed these archaic humans to thrive in their harsh environments. They were true superhumans in many ways, possessing physical and cognitive traits that would be considered extraordinary even by today's standards. One intriguing aspect of Neanderthal biology that deserves further exploration is the remarkable development of their sensory systems, particularly their vision and olfaction. As mentioned earlier, Neanderthal eyes were approximately 15% larger than those of modern humans, providing them with superior visual acuity and night vision capabilities. This enhanced visual prowess was likely a critical adaptation to the low-light conditions and visual challenges of their Pleistocene environment. Imagine being able to spot prey or potential threats from much greater distances, or having the ability to navigate the darkened forests and caves with ease. This visual advantage would have been a significant boon for Neanderthal hunting and survival strategies. But it wasn't just their eyes that set Neanderthals apart. Their olfactory system was also remarkably advanced, with larger nasal cavities and a greater proportion of their brain dedicated to processing scent information. This heightened sense of smell would have been invaluable for tracking prey, detecting predators, and navigating their surroundings using olfactory cues. Researchers speculate that Neanderthals may have even used their sense of smell to communicate and convey important social and emotional information, much like many other mammals do. The ability to detect and interpret subtle scent signals could have played a crucial role in Neanderthal social dynamics, group cohesion, and even mating behaviors. Furthermore, this enhanced olfaction may have provided Neanderthals with a better understanding of their environment, allowing them to detect changes in air currents, identify the presence of water sources, or even sense approaching storms. In the harsh, unpredictable world of the Pleistocene, such sensory advantages could have been the difference between life and death. Interestingly, the development of Neanderthal sensory systems may have come at the expense of certain cognitive functions. As mentioned earlier, their brain anatomy was adapted to support these enhanced perceptual capabilities, with a larger proportion of brain regions dedicated to vision and olfaction. This could have led to a relative reduction in the cognitive resources available for other higher-order functions, such as abstract reasoning, language processing, or social cognition. This trade-off between sensory and cognitive specialization is a fascinating area of inquiry, as it highlights the unique pressures and compromises that shaped the Neanderthal mind. It's possible that their remarkable sensory prowess allowed them to thrive in their environment, but may have also limited their cognitive flexibility and problem-solving abilities in certain domains compared to modern humans. And while Neanderthals are often portrayed as brutish, cave-dwelling hominids, recent archaeological evidence suggests that they were far more technologically advanced and innovative than previously thought. One of the most fascinating aspects of Neanderthal culture is their sophisticated tool-making capabilities, which played a crucial role in their ability to survive and thrive in the challenging Pleistocene environment. Neanderthal tools were not just crude implements, but rather highly specialized and well-crafted instruments designed for specific tasks. They were masters of flint knapping, a technique that involves carefully shaping and sharpening stone to create specialized tools and weapons. These tools ranged from cutting and scraping implements for butchering and processing animal hides to specialized spear points and javelin tips used for hunting large prey. What's truly remarkable about Neanderthal toolmaking is the level of complexity and innovation involved. They demonstrated an understanding of material properties, such as the fracture patterns of flint, and were able to create highly specialized tools with intricate designs tailored to their needs. This level of technological sophistication suggests that Neanderthals possessed advanced cognitive abilities, including the capacity for abstract thought, problem-solving, and even a rudimentary form of engineering. But Neanderthal innovation went beyond just stone tools. They also demonstrated the ability to create complex and diverse forms of art, including cave paintings, engraved jewelry, and even musical instruments. The discovery of Neanderthal flutes carved from the bones of large animals provides compelling evidence that they had a sophisticated understanding of acoustics and a keen appreciation for music and artistic expression. Furthermore, Neanderthals were not just consumers of resources, but also skilled producers. They demonstrated the ability to control fire, which they used for a variety of purposes, including heating, cooking, and even the heat treatment of stone tools to improve their durability and effectiveness. This level of fire control and manipulation is a hallmark of advanced hominid behavior and suggests that Neanderthals were capable of complex planning, problem-solving, and the transmission of knowledge between generations. Perhaps one of the most intriguing aspects of Neanderthal technology and innovation is the evidence of their ability to adapt and make use of new materials and resources as their environment changed. For example, as the Pleistocene climate became increasingly colder, Neanderthals demonstrated the ability to develop more sophisticated clothing and shelters to protect themselves from the elements. This adaptability and innovative spirit was likely key to their survival in the face of significant environmental challenges. As the climate fluctuated and the availability of resources changed, Neanderthals were able to respond by developing new techniques and technologies to ensure their continued success. The technological prowess of Neanderthals is a testament to their remarkable cognitive abilities and problem-solving skills. While they may have been physically distinct from modern humans, their innovative capacity and ability to create specialized tools and artworks suggest that they were far from the brutish, unintelligent hominids that they are sometimes portrayed as. In addition to their remarkable physical and cognitive abilities, Neanderthals also demonstrate a surprising level of social complexity and behavioral sophistication that challenges the long-held stereotypes of these archaic humans. The discovery of Neanderthal burials, many of which include grave goods and evidence of ritual practices, further suggests that they had a deep understanding of mortality and a sense of the spiritual or symbolic importance of their dead. This level of social and emotional investment in the care of their community members, as well as their apparent engagement in ritual behaviors, points to a sophisticated social and cultural awareness that was previously underestimated. Moreover, Neanderthal social structures appear to have been based on a high degree of cooperation and group cohesion. Evidence from archaeological sites indicates that Neanderthals often engaged in coordinated hunting and foraging activities, suggesting a level of strategic planning and division of labor that would have been crucial for their survival in the harsh Pleistocene environment. This cooperative behavior is further supported by the discovery of Neanderthal remains that show signs of injuries or disabilities, yet were still cared for by their community members. The fact that these individuals were able to survive and thrive, despite their physical limitations, speaks to the strong social bonds and mutual support within Neanderthal societies. In addition to their close-knit community structures, Neanderthals also appear to have had a sophisticated system of communication and language. While the exact nature of their linguistic capabilities is still a matter of debate, the size and complexity of their brain structures, as well as the evidence of their technological and cultural achievements, suggest that they were likely capable of more advanced forms of communication than previously assumed. One intriguing hypothesis is that Neanderthals may have used a combination of verbal and nonverbal communication methods, including the use of gestures, facial expressions, and even olfactory cues to convey information and coordinate their social interactions. This multifaceted communication system may have been crucial for maintaining the cohesion and cooperation within their tight-knit social groups. Furthermore, The discovery of Neanderthal artifacts that appear to have been used for symbolic or decorative purposes, such as engraved jewelry and shells, suggests that they may have also engaged in more complex forms of social and cultural expression. These symbolic behaviors, often considered a hallmark of modern human cognition, challenge the notion that Neanderthals were simply primitive, instinct-driven hominids. As Neanderthals stood at the peak of human biology, thriving in the harsh conditions of the Ice Age with unparalleled strength and resilience, they were not without their formidable adversaries. Among these were the dire wolves, woolly rhinoceroses, mammoths, wild horses, and the terrifying short-faced bears. In the annals of human history, there exists a chapter so catastrophic it nearly erased us from existence. Around 900,000 years ago, humanity faced a cataclysmic event that decimated 99% of our population, leaving less than 1,300 survivors. They struggled to endure a world reshaped by unforgiving forces. This wasn't merely a fight for survival, it was a primal battle against nature itself. Even today, the effects of this enigmatic catastrophe linger in our genetic code. Yet, the cause of this near-apocalyptic event remains one of history's most intriguing mysteries. Scientists did a deep dive into the past and revealed that this devastating event and monumental die-off resulted in the extinction of about 98.7% of the population. In other words, a surviving population of just 1,280 people was left after the chaos. Just so you know, this scenario is pretty much how it was for extinct species like dinosaurs and other animals that were wiped off the face of the Earth. Usually, there are always survivors after some planetary devastation event. Still, then even these survivors eventually die off in the aftermath due to overwhelming hardship, falling prey to predators, and a whole of other factors. At this time, humanity was pushed to the brink of extinction, and the survivors merely escaped total annihilation by a hairline. Following their decline in numbers, the critically low population had to endure for another 100,000 years, 117,000 years to be precise, before they could witness a turnaround. Luckily, when this deadly incident took place, things were in their early stages, and even the genes of these ancient ancestors weren't as advanced as they are today. However, an in-depth analysis of over 3,000 modern human genomes showed that there should have been a lot more genetic disparity than we have today. Just in case you're wondering how all of this mysterious history came to light, it's thanks to a recent study that suggests humanity had lost a bunch of its genetic code due to a major catastrophe that occurred thousands of years ago. This study proved that something happened around 60,000 years ago that destroyed a major portion of humanity, thereby greatly limiting our genetic diversity today. Initially, the catastrophe was assumed to be a massive volcanic eruption that occurred 74,000 years ago in the Toba supervolcano. This theory proposed that the eruption was so violent, with an explosive power 10,000 times that of the Hiroshima bomb blast. Such a monumental volcanic blast caused a severe change in climate and weather that nearly wiped off all our species. However, as research deepened, scientists realized that the Toba eruption didn't cause such a profound effect on humanity or the climate overall, as projected. Fossil evidence shows that the actual evolutionary bottleneck occurred about 900,000 years ago. As to the causative agent, it has been traced back to a major shift in climate change, and many fingers in the scientific community have been pointing fingers at the Middle Pleistocene transition event as the main reason behind this mega-climatic change. The Middle Pleistocene transition event was one remarkable event that left experts with many unsolved questions about the Pleistocene era. This transition event was when the short 40,000-year glacial cycle that dominated the Earth changed to a longer one reaching up to 100,000 years. You see, before this time, the Earth's polar regions were characterized by thin ice sheets. But then, afterward, these were replaced by thick ice sheets. The shift was quite intriguing, and the fact that it occurred around 900,000 to 1 million years ago, the same time this mega die-off occurred, makes many experts believe it was the real reason for the near extinction. At one point within the transition, the Earth's climate became extremely cold, and much drier conditions developed throughout Africa and Eurasia, affecting both human and animal species that existed at the time. Creatures may have been forced to adapt to extreme weather and diet changes, and only a few species would have been able to adapt to such drastic changes in such a short amount of time. But in any case, humans at the time may have had it worse, as these ancient Homo species barely had any knowledge of fire, which they could have used for cooking or warming themselves at least. Evidence of fire as a tool dates back to 800,000 years ago, so these ancient humans had to fight the cold the hard way. Some theories suggest the lack of fire was one reason for the great number of deaths, and also suggest that the discovery of fire 100,000 years later was what prevented the total extinction of humanity. As fire became more widespread, humans survived and thrived, regardless of the climatic and environmental hurdles that came their way. Thanks to this, our numbers slowly climbed. So much so that as of 83,000 years ago, the human population had increased by over 2,000%. As time flew by, humanity began to adapt to the changes once more, and other additional technologies like clothing also came into play to improve our odds. However, this doesn't change the fact that a major part of the initial human population was lost, and there were, in fact, several other pieces of the puzzle that needed to be put in place. For instance, scientists are still oblivious as to what Homo species actually got wiped out in this massive extinction event. Ancient human species were quite diverse, ranging from Neanderthals to Homo habilis and Homo naledi. The list goes on and on. Although controversies have emerged over the classification of these species and their actual connection to modern-day humans, experts believe a good number of them existed thousands of years ago, and memories of them were washed away by the sands of time. Some of the species that were wiped out are believed to be similar to Homo heidelbergensis. These species were the last common ancestors between Neanderthals and Homo sapiens. However, not much proof exists to suggest that they were actually the ones who got eliminated. Scientists believe that human genomes have changed over time and adopted various adaptations to make up for climate changes and other environmental factors that may have come into play over the course of millennia. It's perhaps all thanks to these adaptations that our modern-day Homo sapiens have become as phenomenal as we see today. Another piece of the puzzle that scientists and researchers had to contend with was the actual number and species of animals that had gone extinct. You see, while our ancestors may have made it out of this chaotic event in one piece, some animal species weren't so lucky, as they were entirely wiped out. The list includes various genera of pumas and prehistoric predators like the Megantereon and the Xenocyon. Megantereon, for instance, was a unique species, standing at a shoulder height of 80 centimeters or 2.8 feet and weighing about 120 kilos or 265 pounds. These jaguar-like creatures were rampant at one point in time. They were a major nuisance to our ancient ancestors, no thanks to their ferocious nature, voracious appetite, and superb hunting abilities. Somehow, paleontologists believed humans were responsible for the extinction of these species. But this new research suggests this notion isn't entirely true. Megantereon, just like many other animals, may have been wiped out due to this same extinction event that occurred 900,000 years ago. And here's what's really mind-blowing. Creatures in the sea were pretty much affected by this extinction as creatures on land. So far, experts suggest about 100 different marine species were eliminated, which is quite intriguing considering that sea creatures don't have as much to deal with as land creatures. These facts give us an idea of just how extremely difficult life was for many species and how even the toughest of the toughest could survive. But what do you think? Would modern-day humans, with all our genetic flaws, weaknesses, and vulnerabilities, have been able to survive this extreme extinction event? Let us know your thoughts in the comments. For now, there are still many controversies and issues that haven't been properly settled. For instance, some experts deny that climate was to blame, others have issues with the proposed timings, and some others even argue that the extinction event never happened. At the end of the day, more research needs to be done to confirm the accuracy of these figures, as well as verify that the bottleneck extinction event really did take place as hypothesized. One new group of scientists who worked on the theory suggested that it may have happened much earlier, about 1 million years ago. But then again, another study has reconfirmed the earlier date of 900,000 years ago, though this third study believes that climate conditions weren't enough reason for 99% of the human population to disappear from the face of the Earth. From mass migration to mutation, several new additional causes have been theorized as to why this extinction happened. These are just some of the many discrepancies that have popped up over the years since the initial research came to light. Hopefully, we'll get answers to these in the coming years as more research is done on the topic. But until then, we're just grateful our ancestors made it out alive of this near-extinction event. While a fraction of our ancestors made it out alive, the creatures in this video were not so fortunate. Check out this video to learn all about them. Bye for now.